Now, another important topic of propositional logic is quantification. And most of the MCQs and explanation type questions comes from this part of propositional calculus, and this is quantification. So quantification is another way of creating a proposition from propositional function. Like we can further categorize quantification into two different forms. First one is universal quantifications and then existential quantifications. So now I am starting with universal quantification. Px is true for all values of x in the domain. The quantification is denoted by this sign, like universal quantification x of px. The symbol this is called universal quantifier. So consider px stating x is a good batsman, where the domain is the set of all students in a class. Then its universal quantification px is the statement every student in the class is a good batsman. So let me give you another example of universal quantification. Like let px is x plus 4 less than 15 and its universal quantification is x plus 4 less than 15. Universal quantifier x belongs to the set 1, 3, 5, 7, 9, 11, 13, 15. So obviously this proposition is false, cause if the domain set of x is 1, 3, 5, 7, 9, 11, 13 and 15, so then when the value of x will be 11, 13 and 15, then the value of like 11 plus 4 is 15. So 15 less than 15, so this will be not true. And also when the value of x is 13, like 13 plus 4 less than 15, like 17 less than 15, it's also not true. And when the value of x is 15, like 15 plus 4, like 19 less than 15, so then the statement or the universal quantification is also not true for these three values of x. So this is not true, so this is false. So that is why the statement would be true, or the propositional like universal quantification would be true if the domain is taken as like this 1, 2, 3, 4, 5, 6. So for this domain the universal quantification will satisfy, like this condition will satisfy. So then the universal quantification will be true. And now I'm starting with existential quantification. The existential quantification of the propositional function px is the proposition there exists a value of x in the domain for which px is true. So on the domain set there will be a value of x for which px will be true, and that is existential quantification. And this quantification is denoted by this signature. So this is existential quantifier x of px. Now, starting with the first example of existential quantification, let px is x plus 4 less than 15 and domain set is this 1 to 11. So, existential quantification x of px is true for this domain set, cause there exists a value for which x plus 4 is less than 15. So this condition satisfies for this domain set. So existential quantification x px is true. Now coming to the second example of existential quantification, that is, like px is x plus 2 is equal to x. So, and the domain set is the set of all real numbers. So this existential quantification is false for this propositional function, cause 1 plus 2 is equal to 3 and 3 is equal to 1. That is not true. So any real number will never satisfy this condition. So this existential quantification of px is false. And now starting with negating quantification. This is another type of quantification. So if px be a propositional function on a domain A, then it can be proved that negation of universal quantification px has logical equivalence with existential quantification x, negation of px, for x belongs to domain A. And the second condition is negation of existential quantification px has logical equivalence with this universal quantification x, negation of px, for x belongs to domain A. So these two are the conditions for negating quantification. So let me give you an example where the domain set or the universe of discourse is 1, 2, 3, 4. B, the domain of px, x plus 3 is equal to 10. So negation of existential quantification px has logical equivalence with this is the value of px. So we put the value here of px, which is x plus 3 is equal to 10. Then it has logical equivalence with from this second formula of negating quantification. So this satisfies universal quantification x, negation of px. So here this has logical equivalence with x and x plus 3 not equal to 10. So negation of px is x plus 3 not equal to 10. And the domain is 1, 2, 3, 4, or the values of the x are 1, 2, 3, 4. So for 1 plus 3 not equal to 10, because 1 plus 3 is 4, that is not equal to 10. 2 plus 3 not equal to 10 also. 3 plus 3 not equal to 10, that is also true. 4 plus 3 not equal to 10. So this negation of existential quantification x px is true. Now coming to the next example of negating quantification. Let A is 1, 2, 3, 4 be the universe of discourse of the function px stating x plus 3 less than 10. Then the condition negation of universal quantification x px has logical equivalence with existential quantification x, negation of px. So negation of px will be x plus 3 greater than equal to 10, as x plus 3 less than 10. So its negation will be x plus 3 greater than equal to 10. Since 1 plus 3 not greater than equal to 10, also 2 plus 3 not greater than equal to 10, 3 plus 3 also not greater than equal to 10 and 4 plus 3 also not greater than equal to 10. So this negation of universal quantification x px is false. So today I have discussed the quantification types. First there was universal quantification and its examples. Then there was existential quantification and its examples. And then there was negating quantification and the examples. So hope I have made you clear all the topics. And now on the next lecture, I will share a new chapter of discrete mathematics. And till then, please subscribe my channel for these kind of informational lectures and stay connected always, and always press the bell icon to get the notification for whichever video I upload. Thank you.